Back to Calculus 2. We are talking about trigonometric substitution, section 7.4. And I'm telling you right now, no, I'm not going to do what the book did. So the book is going to ask you to recognize and memorize 3 different scenarios, memorize 3 different formulas, apply them when it's necessary, and then good luck when you have to go back into the original x variable, because you will have to do even more work, this time with inverse. I'm going to teach something else. I'm going to teach one systematic approach that solves all the problems, all of them at once. And that is going to utilize the right triangle with the Pythagorean theorem. So we're going to review that. So toolbox first, right? What do we need? We have ABC, right triangle, and we are able to write Pythagorean theorem a squared plus b squared is equal to c squared. And we are also able to write that a squared is equal to c squared minus b squared. And we are also able to write that b squared is equal to c squared minus a squared. And at this point, I'm just going to erase the first equation and write c squared first, so that we can compare all the equations at once. So I'm just rewriting the first equation as c squared is equal to a squared plus b squared, but it's still the same thing. And at this point, we are going to stare at the formula, all 3 of these, and realize that if you have a negative sign, c squared is always the first, right? And the second is the leg, either a or b. And if it's a plus, you have the legs, 2 legs there. So what I'm saying is, one more time, if there is a minus sign, which is the last 2 rows, this is the hypotenuse. And these are legs. If there is a plus sign, both are legs. This is a pattern. This is all we need. We also need to know opposite over adjacent is tangent. Thank you. Whew. I tried to trick you there. And I got really concerned with things. Awesome. So I will immediately post a question, and we'll take a look at how it's done. So it really, I'm skipping the entire thing, just going directly into the exercises for the homework. So let's integrate. Integral of 100 minus x squared dx. So this is where the skills are. You draw the right triangle. You label angle theta. You can label also the right angle if you want to. And then you look at your problem. Realize this is 10 squared, right? And you are supposed to assign number 10 and the variable x to 2 out of the 3 sides on the triangle. Now remember, you're using your eyes to look at the problem, and you see that minus sign. As soon as you see the minus sign, you know that 10 goes where? Hypotenuse. So there is no doubt about that. It should be automatic response because you know this. If there is a minus sign, this is your hypotenuse. There is a minus sign. whether this is 10 or x or whatever the hell it is, it goes on the hypotenuse. That is a must. Has to be. This, you get to put on any of the legs you want. It doesn't matter, because these two formulas are symmetrical. So you can put here, or you can put there. It doesn't matter. So we placed 10 on the hypotenuse because we had to. And now we can place x on any of these two. Let's put it here. Now that immediately means that this thing is 100 minus x squared, because you will use Pythagorean Theorem to find the third side. And when you use Pythagorean Theorem to find the third side, it's going to be x squared over here plus unknown squared is equal to 10 squared, which is 100. When you solve it for the unknown, you get this square root. And you will see that that's always the case. So if you get through this setup, and if you understand this setup, you are done with this lecture. There's nothing else. Now you look at this triangle, you write your trigonometric functions, you substitute them here, and you solve 7.3, because then you will have trig integral to work on. So now we start by writing the trigonometric functions. Oh yes, that's very important. You always write trigonometric functions towards the number. So one of these three sides will just have a number there. In this case, 10. Write trigonometric functions towards the number, which means that you will use a side, one of the sides, and the number, and then the other of the sides and the number. And that's why I circle them this way. So when you are looking at this, you see that you have x and 10, that's opposite over hypotenuse, which is very good. Sine theta is equal to x over 10. You can solve that as x equals 10 sine theta. And upon differentiation, 10 cosine theta d theta. Let's review this one more time. Once you have your triangle with all three sides populated with values, you will write either sine x, cosine x, tangent x, secant x. You will write a trigonometric function utilizing the side with a number with whatever other side, and then go back to the side with a number with the other side. Once you have that, so I pick this one. See how I circle that? I always circle this side and the number, and then let's go. Opposite of the angle and the hypotenuse, the longest side of the triangle, opposite over hypotenuse is sine. Solve for x and immediately get dx. It's a substitution, right? You get u du immediately, right? When you differentiate. So this is x dx, differentiate immediately. You will be working in terms of d theta now. You are casting your x domain into theta domain. So it's like u du substitution, except you're now getting theta d theta substitution, but it's actually sine theta or cosine theta d theta, because it is trig in there.
You said you're casting what?
X into thetas. See, x is in terms of thetas. So now you have dx in terms of d thetas. And now, yeah, the theta, yes, x is u, and a theta is x. It's just Now for the second function, I am writing that the cosine theta is equal to the adjacent, which is the square root, over the hypotenuse, from where the square root is equal to 10 cosine theta. It's a little bit convoluted to get it, but once you, this is awesome because it solves all the problems. I hope you guys see substitution now. You see how the square root is equal to 10 cosine theta? You write that instead of this. And instead of dx, you have this. So you have 10 cosine theta times dx, which is another 10 cosine theta d theta. Replacing. And I'm going to replace the square root with what square root is. And I'm going to replace dx with what dx is. All right, meditate on this. Every single problem is done this way. Every single one. There's no need to memorize cases. There's no need to memorize formulas. If you understand what happened here, this solves all of the problems. Yes?
That's 10 cosine theta dx or dx?
D theta. dx equals 10 cosine theta d theta. So we are replacing pieces of the integral that had x with new pieces which have thetas. So square root of 100 minus x squared gets replaced by 10 cosine theta, which we obtained from the triangle. And the dx gets replaced by 10 cosine theta d theta. And now you will have 100 cosine squared theta d theta. Power reduced, solved, and then we'll see what. Because then you have to go back to x's. Cheers.
And you know when you do this kind of stuff,
When you see a square root like this. No, when you see a square root like this. Okay. Well, we'll talk about this. We want to get the mechanics first, and then there's going to be, guys, 7.6 is a lecture that is focusing on which method to use when. So there's a whole section which says it's basic, it's your side, it's trig side, it's partial rational computation. Can't wait, huh? I know. Such as that.
You can divide it down, so it can be any two great cosine squared. 100 cosine. Yeah.
Can't get rid of it.
Well, that's what I'm saying. Like you just divide it out, like outside of the integral.
Let's not divide out, let's factor out, or pull out. Pull out.
Pull out.
Not even factor out. So I'm going to remove these marks now.
Yes.
Oh, you didn't like the marks? Oh, okay. Marks have been removed. You are the Legion. Okay. So we have 10 cosine theta times 10 cosine theta d theta, which is 100 cosine squared theta d theta, which is 50 integral of 1 plus cosine 2 theta. Don't forget the parentheses. And now we are ready to integrate, which is 50 times theta plus integral of cosine is sine. So we have 1/2 sine 2 theta plus c at the end. And now there is this piece of, I don't care about theta, I care about the x. We can't leave the answer like this. So we have to go back and solve and leave our answer in terms of x's. So this is where this method of solving problem is superior, because you already have what sine is equal to, what cosine is equal to, and you can just plug them in. And then there is this little piece of, you don't have what theta alone is equal to, but you can solve any one of these for theta by either hitting this equation here by inverse sine on both sides, or hitting this equation here by inverse cosine on both sides. So let's go. 50. Now we have inverse sine. So that's sine minus 1, or you could write arc sine of x over 10 plus 1/2 of 2 times sine theta cosine theta. You break that apart using the formula from trig, and then these 2's cancel. So the final answer here is 50 sine minus 1 x over 10 plus, and then sine theta is x over 10, and the cosine theta is square root over 10. Plus c. And the only thing you can do is combine the second term a little bit, simplify it. And we are done. So after doing about 10 problems, I found that still the hardest part for students is to do this transformation at the end from thetas back into x's. So I will repeat that a few times. Let's see, any questions? Yes?
So, wait, sine of 2 theta is, oh yeah, 2 sine, never mind.
Right, that's a double angle formula. Sine 2x is 2 sine x cosine x. Now we'll just use the thetas instead. Are you ready for the from here expansion into this? That's, yeah. So I'm going to explain this problem from scratch, and then we're going to do another one, and then we'll do a whole bunch of these next week. But you will hopefully try this over the weekend. Easy, easy. So we're starting this problem by first realizing that the 100 can be written as 10 squared. Now, if you have a number that it's not perfect square, well, you can still write it as a square root of that. So if it was 3 minus x squared, it's just going to be a square root of 3 there, right? Doesn't matter. So 100, that was nice because it was 10 squared. And we have 10 there because it was minus, so that's the hypotenuse. And then x can go on either one of these, it doesn't matter. And as you solve the Pythagorean theorem, this will pop out. Now you will see that as you go through these problems, it's always the case, so you will automatically put the square root that appears in a problem on the third side. And then we create trigonometric functions, whether it's sine, cosine, tangent, towards the number. So you will always have 3 sides because it's a triangle. One of them is always a number, and then you're left with 2 other sides. So those 2 other sides will each take a number with it to create trig functions. That is the standard. That's how you do all of the problems. So x and 10, opposite over hypotenuse, sine, solve for x, and then dx, have those substitutions. Use the other pair, 10 and square root. So that's adjacent hypotenuse, which is cosine, adjacent over hypotenuse. Solve for square root, because, guys, it is the square root that you need to replace. That's why you're taking this equation and solving for square root. You want to get rid of the square root and replace it with something easier to deal with, which is cosine x. So we are replacing the square root with cosine, 10 cosine x, theta. We are replacing dx with 10 cosine theta d theta, which is this. 10 times 10 is 100, kick it outside. Cosine times cosine is cosine squared theta d theta. And the rest are now your skills in solving integrals. How do I integrate cosine squared? Well, I have to do the power reducing, which is over 2, but that cut 100 into 50, right? And then integral of 1 d theta is theta. Integral of cosine is 1/2 sine 2 theta plus c. I don't care about theta, I care about the x, right? So we have to go back to x domain. To go back to x domain, you simply replace your sine and cosine functions with their definitions from the triangle. But you also have them here and here. Now the problem is that we had a single theta. It was not sine theta, it was not cosine theta, it was just theta. So how do I get out of this expression just theta? Well, I apply inverse sine on both sides. Inverse sine will kill the sine, leaving only theta. And that's how I got this inverse sine term here. So it was from our substitution, which was already on the page, because we had to have it. I used that, and I hit both sides by the inverse sine, and that left me with x over 10. Now I could have done the same to the other for the cosine side, in which case that term over there would read inverse cosine of square root of right over 10. But this is less writing, so we went with this one. The second term, between this and this, we are using the formula for reduction, right, the double angle. And then those half and 2 cancel. And guys, look, you have sine theta. That is like a block. You replace that block with what sine theta is right here. Sine theta is x over 10. So I'm literally replacing these. They need to get me to scroll here. I'm replacing this sine theta with x over 10. This died, right? And I'm replacing the cosine theta with the square root over 10, which is, again, from the substitution up there. If you don't have them, not a problem. Just read it off the triangle. You have the triangle. That is the biggest problem if you do the way the book does it. Because if you memorize the formula from the book, you do not have the triangle. And when it's time to go back, if the functions don't match, good luck. Right? That's the problem. So if you do it this way, it is the fastest way, and it works for all problems across the board. No cases, no formulas to memorize, nothing. You are utilizing 100% what you know from before. The only thing that you have to memorize here is how to appropriately place the values, and that your trig functions needs to be towards the number. That's technically it. The rest is all pre-calculus knowledge, calculus 1 knowledge, and then good luck with the trig integral that you have to solve. Hopefully it's easy, right? But it could be very bad. Yes? That's the trick. It doesn't matter which one goes on which leg. Legs we don't worry about that, because in terms of legs, everything is symmetric. You have a sine cosine pair, which could be swapped. It's okay. And then if you swap the legs for the secant tangent pair, you're just going to get cosecant cotangent pair. So technically, and you will see that if you set this triangle up in one way, and you get the cosecant cotangent pair, all you need to do is to swap the legs, and if you redo the problem, it will be secant tangent pair.
We'll say that is square root is 1 function plus x squared, because both still on the legs.
Yes, very good. The question is, if this was a plus, what happens?
And
Then 10 and x go on these.
then the hypotenuse would just be
Would be the square root, yes. But as I said, these guys being x and 10 or 10 and x, it doesn't matter, because you're either getting secant tangent or cosecant cotangent pair. And if you really don't want to do it as a cosecant cotangent pair, just swap them, and it will become secant tangent pair. Let's take a look at another example before the time expires. Another example, we're not going to go anything crazy spicy. Let's go with integral. Now this is a definite integral, but I'm going to skip on for the, in the interest of time. So I'm not going to put limits. So now we see the square root there. Again, it's a minus. If it's a minus, the one on the left is the hypotenuse. The one on the right is one of the legs. So for me, it's automatic. For you, it will take time. You're completely ignoring this. It's not under square root. You're completely ignoring it. That could have been x to the 10, single x, doesn't matter. You are only using the square root values to populate your triangle. Once you have this, you will write your trigonometric functions, again, using a number, which is in this case 1, so 1 and x, and then 1 and the square root. So again, sine theta is x over 1, which means x is equal to sine theta. So dx is cosine theta d theta. On the other side, I have that the cosine theta is equal to the square root of 1 minus x squared over 1, from where square root of 1 minus x squared is cosine theta. So now, all I need to do is to plug this in. Integral, I have a division line. The square root gets replaced by cosine theta. Dx gets replaced by cosine theta d theta. And what do I do with x squared? Sine squared. Very good. If you pay attention, you have what single x is equal to. Just need to find it, where it is. So if single x is sine theta, then x squared is sine squared. Sine squared theta.
Can you use this to calculate the arc length formula?
Circumference of the circle is a lot of cool stuff you can do this. So now,
So, in this case, like, is it a trick where, like, that you're only differentiating sine and theta in this case, right? So that's why, right? Now, how do you know which one to differentiate?
you can only differentiate single x.
The one without the
Exactly. Square root is just going to give you mess, right? There's always going to be one that will be plain vanilla like that, always. And you will see as soon, this will become such an easy going pattern. When you do 10 problems, it will be a living nightmare for the first 1 or 2 problems, so you just need to persist through that. And after this, it's going to fly. It's going to fly. Because you will see it as such a pattern as soon as you put, because, right, one of these is x squared. There's going to be an x somewhere. It's going to be x in one of the 2 equations. Once you solve for it, dx is immediately around the corner. Plugging everything in.
You said the reason you're not doing the derivative of the cosine theta is because the square root is
I would say the only issue, the only problem with these is now computing the trigonometric integral that you get. That is, how good you are with 7.3, which is the lecture we took care of when we started today. So now you have over there, as you can see, you have a cosine squared theta over sine squared theta.
Which is tangent squared theta. Oh no.
It's a cotangent squared theta. And I'm just going to say good luck. Yeah? You just ruined it for everyone. He just ruined it for everyone. All right. I was thinking, people go home, suffer and cry for some time, and then, yeah. And he goes like, yeah, Pythagorean, it's obvious. It's like, yeah. So cotangent is going to be cosecant squared minus 1. Sorry, these are thetas. And cosecant squared is the basic, right? What's the integral of cosecant squared? What do you mean, yeah? That's a wrong answer. That's -5 on the test. What's the integral of cosecant squared theta? Negative cotangent theta. And then we have minus theta, right? Because the integral of -1 d theta is negative theta. Plus c. And you see, we ended up with a cotangent theta in the answer. My basic functions, which I pulled over here, sorry, right there, basic functions do not have cotangent theta. But I don't despair because I have the triangle. What's the cotangent in terms of adjacents and stuff? Adjacent over opposite, so square root over x. Negative square root of 1 minus x squared over x. Minus, for theta, you can do the inverse for either one of these, so inverse sine of x. And you have your plus c. And look at that, 5 seconds before the time. All right, stream, bye-bye.